We'll get this going here. All right. So we're back kind of in the book, but although your don't worry about that. Left my phone on. Your homework is actually a worksheet. Okay, so that's fine. Oh my gosh. Okay. So conditional probability is, let's just put this down. Let's go in red so it pops a little bit. The is it, oh, it's frozen. Not on the movie, but in the class. The probability an event occurs that's just 1 hour, right? Given that that's not a 6. Oh my goodness. Let's pause the video for a second. This one's my fault. Given that another event has already occurred. That's the conditional part. Still feels weird to write. We went through this last hour. It is 2 C's and 2 R's. We looked it up. No. Oh my gosh. Again, this computer's... I just hit pause. So this next notation is, if I can write it, this is the probability of A happening given, I'm not going to write happen or occurred again, probability of A given that B happened or occurred. Let's put happened. Wait, is that 2 N's or 1? Is it just 1? I never was good at English. So let's move on. But my day was good other than that until whatever just happened in 6 hour happened. Okay, so this is the probability, of course, that A happened given that B happened first. So to find the probability of A given that B has happened, this is what you have to do. And then we'll see what ends up happening. Okay, and then don't worry about it. But what does that word mean right there, the upside down thing? It does mean and. It actually means not union, because that's a U. It's intersection, or what do they have in common? The overlap. Divided by the probability of B, because B has already occurred. We're assuming that that has happened. The only reason we have this is the probability of B happening given that A has already occurred. So this is A union B, or you could say B union A. Does it really matter, though? But divided by the probability of A occurring because A has already occurred, as we look at it that way. So take a minute to write this chart down and maybe the first 2 questions, and then we'll do. Find the probability that a randomly selected student has blonde hair. Is there anything special about that statement? No. How many blonde hairs are there in this little thing? 74. Learn how to read the chart, I guess, or I don't know. I mean, learn how to sounded rude, but. And then how many total are there? 102. And then just for purposes of not annoying me, reduce your fractions if you decide to leave it as a fraction. You don't have to leave it as a fraction, though. You can make it a decimal, and then you can turn it into. But if you leave it as a decimal, you better learn how to round. You're seniors in high school. Okay, what does a 4 do after a number? Round up or down? Down. What's a 5 do? Come on, how are we rounding incorrectly? So could someone tell me what so if that's what you get as a decimal, make a choice. If you change it to a percent, you should at least be going to the 10th. You should leave that little thing on there. You shouldn't say 73%. You should at least give a 10th for a little bit more accuracy. And this 4 keeps the 5 a 5. That's how you do it. And don't be doing this. Some people do this. 9 makes that 4 a 5, and then 5 makes this a 6. Then you're wrong. If you decided to go to 3 decimal places, I don't know why I'm doing this, because this is grade school stuff. Sorry. You better know all that. If I go to 2 decimal places on the percent, then the 9 hits the 4 up to a 5. I'm done with that little lesson. Okay, now, here's where we have something. These are going to stick out like a sore thumb because that word is going to be in there. It gives a condition. This makes it conditional probability how we actually have to do this. Excuse me. Find the probability that the randomly selected student has blonde hair given that his or her GPA is between 3.0 and 3.5. So this is the probability of, did I say blonde? Because sometimes I said, because the other one starts with a BR or B, I mean, but blonde, sorry. Just talking about my mistakes that I've done earlier today. Given that we have a 3.0 through 3.5, maybe I'll do that symbol. So what we have to do for this is, given that that has occurred, given that we are only selecting from that list, is really how it looks and how we perceive this. But if we put this together with how the formula works, it's the probability of the intersection of both events, which just means who is blonde and has a 3.0 to 3.5, divided by the probability of the 3.0 to 3.5 list, because that's the condition. So how many blonde 3.0 to 3.5s are there? Well, here's blonde, and here's 3.0 to 3.5. What's that answer? 40. Out of how many total? Where's the whole? How many total of the whole selections? 102. That's the top, and then of course we'll see what happens. Just relax. What's the total 3.0 to 3.5 list? 50. How many do you have to choose from? 102. What happens with the 102s? What? I had a number in my head. Sorry. What number did I have in my head, actually? 0.8. That's why I accidentally wrote a... Okay, next one. What is this? Find a probability has a GPA of 3.0 given that he or she is blonde. This is the reverse of that last situation, right? And then the only point to this, I guess, is will this be equal to the last one? And actually it won't. You'll see that. Okay, so what's the intersection, again, of 3.0 to 3.5? Sorry. Intersected with blonde. How many people are both those things? How many was it? Out of? But then how many are blonde? We can look at that on the list. Is it 74? And then what happens with the 102s? So really it should just be, 40 out of 74. 40 out of the total 74, given that. So we're really looking at the blonde list. All right, you could divide by 2. Is that 20 over 37 possibly? But I really would prefer and make it easier on yourselves just to get the decimals and you could do that. I'm not. That's ridiculous. Even put in the movie. You can't get a decimal around it. What are you doing in here? Next, go ahead and write this question down, but we're not going to do it yet. I'm going to do it after we do the next set of notes. I didn't do that first hour. Sorry, first hour. But as you're writing it down, I'll yammer about this. How many students am I selecting in letter D? 2. How many did I select in C? That's what you have to understand. We only picked one student in C. We just wanted a probability, that conditional probability, that they were a blonde with 3.3 to 3.0 out of the whole total amount of blondes that there are in the list. You only have one student. This one you have 2. The first one has brown and the second one has blonde. Given that, that's the conditional part, their GPA is between 2.5 to 2. Sorry, I did that in reverse. The reason I'm going to wait on that is this is actually a term. We'll go back to this before, so give yourself some space to do this. And then go to this, and then we got to go back. This is actually a dependent event. is the way we have to treat it. An independent event, just to make sure I say this, the occurrence, let's say, of the first event, or just of an event, does not affect, I'm just going to put this in a way, affect future events right after that. So dependent is the opposite of that. A dependent event, the first event affects the probability of the next event. It changes the numbers, let's say. So that's what we got to be aware of. And we already know this. We already done this question. What's the probability I pick a king and then I pick another king? Okay, how many cards do I have in my hand? 2, and it's an and. And I don't replace the first king. So what's the probability I pick the first king? How many kings are there? 4 out of 52. But then what's the probability I and pick another king after I pick the first one? 3 out of 51. Mark it as dependent. The second pick depended upon the first pick happening, and it also affected the second pick because it affected the amount of numbers. So that's what dependent is. And we've done that. We've already actually have that somewhere in the notes. I forget where. It was 10.1, 10.2, somewhere around there. So if they are independent, and again, when we're talking about dependent or independent events, we have 2 or more events occurring. We have 2 cards in our hand. This is the only way we talk about this. The word or, I know I'm confusing you, but I want to get your mind in the right spot. What if I say, what's the probability I get a king or a queen? Stop and think about that for a second. How many cards do I have in my hand when I'm done? Just 1. I just want to know what's the probability it's a king or a queen. All right, and it's 8 out of 52. 4 out of 52 plus 4 out of 52. That's why or is plus. And is times. So what's the probability of A and B occurring? Probability of A times the probability of B. Remember we said this means and when you see that intersection. Use a little bit different than what we had up there. It also means intersection when you're trying to get your list together. That was easy for me to say. When it's dependent, the notation just means the probability of A times the probability of B, assuming that A has already occurred and it affects the numbers of B's process. Why this is both conditional and a dependent scenario is very simple. You have to think about, after I pick the first student, how many students are there? 102. Then when I go to pick the second student, how many are there? 101. So that's why I wanted to do that. I wanted to make sure you understand that. Okay, so what we need is the probability of Brown, BR, given that, I want to write this in the right notation, given that they have this GPA, and, what's the word and mean? Times, right? Probability, get rid of that and, it looks terrible, of blonde, given that they're in this list. But the second one depends upon the first one happening, so it affects their numbers. It's kind of putting those 2 things together. Okay, so let's do it one more time. Probability of Brown intersection, wrong word. What's the overlap of these 2? Divided by the probability of this overall list, because given that, we're choosing from that list, times the probability of the blondes that are in the 2.0 to 2.5 list, divided by given that the first event occurs. So we got to change those numbers a little bit. Okay, how many brown hair people are in the 2.0 to 2.5 list? Look at your chart. Is it 18? Can we get a... Is there 18 in the both brown and in the 2.0 to 2.5 list? How many total in that overall? Sorry, how many total overall? 102. How many are in the 2.0 to 2.5 list? 52 out of 102. Times, let's just finish this off, then we'll do the canceling. All right, how many, now this person is picked, so that's why we have to understand that that person's picked. How many people are in the blonde and 2.0 to 2.5 list? 34. That stays, because that person has been picked, but what changes? 101. And then something changes down here. How many total people are in the 2.0 to 2.5 list? 51 out of 101. And then we could understand that this is always going to happen. These are always going to cancel, so really it's 18 out of 52 times 34 blondes that are in that 2.0 to 2.5 list divided by 51 leftovers. All right, and then you can multiply across, and then divide and just get that as a decimal. Don't rack your brain about making this a fraction that's in its reduced form. That's what they agreed was the answer. Oh, I'm still taping. That was fun. Determine if the events are independent, and then find the probability. Here we go. It's very carefully worded. Selecting a king and then selecting a queen without replacement. Is this dependent or independent? Of course it's dependent. Two ways I've always looked at this, but first of all, how many kings are there in a deck? Standard deck, how many total? 52. And then I make my second selection. First, we assume the first selection happened, and you got what you wanted to get. And then the second selection is affected. But how many queens are there? 4. Is that affected by a king getting picked? No, just make sure we understand that. Divided by how many? 51. You got it. It's easy. Go ahead and multiply cross. And this is 1 over 13 if you want to be a fraction person. And then this is 4 out of 663. I just remember that. I didn't just calculate that. Is that right anyway? I don't know. I may have forgotten. The brain ain't what it used to be. All right. Tossing a coin and getting heads, and then rolling a die and getting a 5. Does anyone affect the other? No. What's the probability of getting heads? Half? What's the and then rolling a die and getting a 5. This is 1/12, which I remember, and I should have known this. I was upset with myself. I think. All right. Then you got this scenario. The probability that a salmon swims successfully through a waterfall is 85%. That seems high because you ever see those videos of the bears eating them, going crazy? Does the fact that a salmon makes it, the next salmon's probability of making it is affected? Yes or no? No. That's what this is, an independent scenario. This is done through maybe observation, somehow, some way, observing or at least calculating the probability, like how many salmon swam, and then they could easily calculate how many the bears got, and then through that they could say 85% of the time a salmon will make it. So if one salmon makes it, it doesn't affect the next salmon's chance. This is independent. Okay, now this last one can be tricky. As a matter of fact, I should almost cross this one off, because how you do this last one, you probably should do considering that. Remember I said that. Okay, because the third one could be a problem. And I thought about this after first hour. But the first one's easy. What's the probability that all three are successful? Guess what we're going to do? This is the first one makes it, and the next one makes it, and the next one makes it. What's the probability that all three make it? That's how you have to word it. The first one, and the second, and the third. What's the probability the first one makes it? 85. What's the probability the second one makes it? What's the probability the third one makes it? And then we'll find that number. By the way, you guys, 614? You guys have been the best. First hour didn't do anything. They just looked at me like they wanted to kill me. Hey, can you just calculate for me? One person flipped me off. It was unbelievable. And I'm yelling at this person in 6 hour for doing whatever. You be quiet, sir. I'm telling you, you're on the... All right? Nothing. We sat here for 5 minutes. No one could calculate that for me. Thanks a lot, first hour. All right, next one. What's the probability none are successful? Isn't it the same? I mean, the same what I have to do. Fail, and eaten horrifically. So what does this become? 0.15? 0.15? 0.15. And then we'll type that out. That's a small one. So very not likely. This is not 34%. This is 0.34%. Less than 1%. Very unlikely. Now we have a problem. Because what is at least one is successful? That means one is successful, or two, or three. And I was thinking about this morning, and I wrote it on their notes, but there's a problem with this. Let's do one is successful. Well, which one? So it could be the first is successful, and then the second and the third isn't. Or the first fails, the second makes it, and the third doesn't. Or fail, success. How many different ways can one make it? No, three. That was 3 different ways. And then how many different ways could two make it and one not? It's the same. It's 3. And then how many ways could all 3 of them make it? There is only one way to do that. So that's hard, and you probably wouldn't have known that. And actually, when I was thinking about it this morning, I didn't account for that initially. It's actually kind of like a binomial distribution. There's 3 ways that this could happen. But we don't have to do any of that. What is the opposite of 1 or 2 or 3 making it? None of them making it. It's the opposite. This is the complement. So actually what we could do, at least one is successful, is 1 minus the previous question. So that's why I said when we first did this, even if we didn't ask to, I would say, well, it's either this or it's 1 minus the probability of 0 making it. Because it's the opposite of what's being asked. It's the complement, if you will. So again, I think this has happened in a lot of the notes. If something seems like it's going to be very lengthy to do, think about the complement of the scenario, and then it ends up being easier. What does this end up being? 0.99, what? 6 or 6, depending on how you rounded. So you don't want to round this to 100. You want to say 99.7 maybe percent. Done.